Alright, so let's go ahead and write some things about R while we're here. I can go ahead and tell you R is extremely, extremely important. I can guarantee you that you will see multiple choice questions both on my test and on the AP exam about just R. It tells us two different things that we just wrote. What are the two different things it tells us?
Strength and direction.
It tells us strength and direction. Now, it's not just of a relationship. We are only measuring a linear relationship. Between variables. So, like, is there a very obvious relationship in that graph? R would tell you that's terrible because R can only measure this. So it's probably going to have something like moderate. Even though there's a very obvious pattern there, it's a very, very strong pattern there. The only thing R can measure is how strong and direction of a linear relationship. What's the lowest that R can be? We wrote this already. 81. What's the highest that R can be? That is a very common question, is something about that. You get an R value of negative 1.24. What does that mean? It means you did something wrong. And that's like literally a question that I've either had on a test before or I've seen on the AP exam before. Being one of the answer choices, you should never get an R outside of there. If you did, something's wrong. In general, what do you think? What did we first talk about with, what does that mean?
It's all over the place.
It's all over the place. Now, it's easy to explain to you at first that if it's all over the place, it's zero. But if it's zero, it doesn't necessarily mean that it's all over the place. There's no what kind of relationship?
Linear.
There's no linear relationship. So even it could be something that's like,
That could be zero.
this might even end up being zero. That would make sense to be zero, right? Trying to think about where I'm going from there. That one might not be zero, but you can see how there could be a definite pattern that's not going to show up. So this doesn't mean no pattern, just not linear. Now, we're, for the most part, going to see ones that, if I give you a graph and ask you which one's zero, it's going to be one that's all over the place. I'm not going to ask you to do something like the one I just drew up here. R actually is the word correlation. You're saying there. Words that are really important in our class that don't ever say it unless you mean it. Mean, average, normal, and correlation. Those are three of the biggest ones. You can't say there is a correlation between unless you are literally talking about R. Those two values look like they are very highly correlated. No, because that is not measuring R. So this is another one of those trigger words where unless you literally mean R, never use the word correlated. Probably in chapter 1 and 2, I wrote stuff on your tests that said correlation means something else, but you don't know that yet. I'm not going to get into all the details, but line of best fit is a least squared regression line. If I make a line, what? I can make boxes, perfect squares, to get myself back to that line. You see what I'm doing there? And I can do it from this way. Oh, that was not a good one. From here, it'd be the same thing, but so do you see how I'm making perfect squares to get myself to the line? If I shaded all these in, and took the area of every single square that was made here, I am shifting this line. The calculator, the computer is shifting this line until the area of all those boxes is the smallest. And that's literally why it's called the least squared regression line. Which means it is constantly reevaluating different means. Are means resistant to outliers? So if I have an outlier, is it going to affect my mean a lot? Is that outlier going to affect this mean? So is mean resistant? No. This is calculated from mean, so R is also not resistant.
How is R calculated from me?
We don't have to go into the math part of it, but like how I kept like talking about the boxes, it's constantly finding them. Yeah, you don't have to get into all that. Based on mean, calculated from mean, something like that.
Should we say it's not resistant to outliers?
If you want to, you can think about it that way. There are other things that can be resistant. Don't write this word. When did we talk about that word? First quarter. I think first quarter. You can only determine this if it is an experiment. Do you see a really good relationship with the paper we're dealing with? Did we do an experiment? No. So, is there a high correlation here? But does that mean one of them caused the other one? Because we did not do an experiment. That still holds, and people always forget that. So correlation does not necessarily mean causation.
I think we won extra dot.
Good. I need to know that. I just kind of reminder, causation is only if we did a well-designed experiment.
Only if experiment?
Only if it's an experiment, sorry, I'll add that in later. You don't need to go calculate this, but all that R is measuring this is not a mathematical representation of what R calculates. But it makes sense to think about it this way. R cares about this. I can smush them into here and get all of them in a straight line. Does that make sense? There's a lot more to what R actually does, but that's kind of what R is thinking about. If I switched my X and my Y, do these red lines change? They're going to change where they are, but if all I'm thinking about is I can switch them to here, does where I can switch them to change if I switch my X and my Y? So R actually doesn't care or know at all which one's your X and which one's your Y. That's supposed to be an R. And in that same aspect,
It doesn't matter which what.
it doesn't matter which is your X and which is your Y. Like if I switch points per game and yards per game in my graph, R wouldn't change at all.
Okay.
Yeah. Alright, so what's down here right now? Yards per game? Right? Well, let's say I don't understand yards, I don't want to deal with yards, and I want to deal with feet instead. I had no numbers written when I had yards per game, right? When I now switch to here, what happens about my graph?
It's long.
But if I don't have any numbers written, wouldn't my numbers just change? So like, we'll do something easy. If this were 300 yards, how many feet is that? Oh, I should have done the other way.
900.
So I just changed what my numbers are. Nothing changed about my scale, right? So does R care if we change the units? No.
As long as they match up.
So these are things that you would see in a multiple choice, and you should expect to see them, and you should expect to see them on your test. Now, once we have more examples, then I'll go over some stuff with those, but everything kind of stems off of the bullet points we just wrote. Now I gotta go a little quicker.